Hi, I'm Miss Hearn. Let's get started. In this video, we're going to answer a question sent to me by one of my students. It's from one of my math lab homework assignments. We're using a Blitzer college algebra book, and it says the function f of x equals x plus 6 over x minus 3 is 1 to 1. For the function a, find an equation for f inverse of x, the inverse function, and b, verify that your equation is correct by showing that the composition of f and f inverse in either order is equal to x. To start with, for part A, we're going to follow a four-step process to find the inverse. We know the inverse exists because we're told the function is 1 to 1. So the four-step process we'll use is to replace f of x with y, switch x and y, solve for y, and then replace y with f inverse of x. So let's start by copying down our function, except we're going to replace f of x with y. It's just easier to use y notation. So we're going to say y equals x plus 6 over x minus 3. Now, this is our original function, just in a different notation. What we would like is the function where all the x and y's are switched, so we're going to do exactly that. Wherever we have a y, we're going to put an x. Wherever we have an x, we're going to put a y. So we get x equals y plus 6 over y minus 3. Now here's the tricky part of this problem. How do you solve for y? So this is like when you probably learned in the previous math class how to rearrange a formula for one of the variables. The first thing that we're going to do is we're going to multiply, since this is a rational equation, meaning that it has a fraction in it. One of the things you can do to solve a rational equation, whether it has more than one variable or not, is to multiply both sides by the least common denominator. So in this case, we're going to multiply both sides by the only denominator there is, which is y minus 3. When we do that, we can cancel the denominator on the right. Y minus 3 divided by y minus 3 is just 1. 1 times anything is itself. So on the left, we have y minus 3 times x, and on the right, we just have y plus 6. Now we have parentheses, so we're going to distribute through those parentheses, and we're going to get xy minus 3x equals y plus 6. Whenever you're solving for one variable in terms of another, what you want to do is get any terms that have the variable you're looking for on one side and all the other terms to the other. So I'm going to move this y that's on the right over to the left by subtracting y from both sides. But I'm also going to move this 3x from the left over to the right. So that way I'll have all my y's on one side and everything else to the other. So we'll have xy minus y equals 6 plus 3x, or 3x plus 6. The order doesn't matter since addition's commutative. All right, now the variable you're looking for appears twice. Whenever that happens, the little trick you use is to factor it out so that it only appears once. So factoring out the y, we're left with x minus 1, and the right-hand side stays the same. And then the last step is going to be to divide that x minus 1 over to the other side, so we get y equals 6 plus 3x over x minus 1. So that's how you solve for y whenever you have a function like this one. The steps are almost identical anytime you have a rational function of this type. All right, so now we're going to do the last thing, which is to give him his name. This is a new function. It's the inverse of the original, so we're going to call him that. We're going to write, instead of y, f inverse of x equals 6 plus 3x over x minus 1. So we have found that f inverse of x equals 6 plus 3x over x minus 1 is the inverse of f of x equals x plus 6 over x minus 3. Now, one characteristic of inverse functions is that if you compose them, that is, to plug one into the other, you should always end up getting an x back. In the next video, we're going to confirm that for these two functions, that's actually the case. I hope you found this video helpful. If you did, please give it a thumbs up. That helps other students